Good afternoon. I am Anirban. I'm an assistant professor in mechanical engineering at the College of Engineering at West Texas A&M. And I'm going to be talking about high performance computing, and maybe I should say high throughput computing as well, in the Texas Panhandle and beyond. So my background, so let me tell you a little bit about me. So I have a background in mechanical engineering, and during my graduate school, I did a lot of computational work. And so just getting into this business of acquiring a high performance computing cluster at this university was a little bit intimidating at first, because as I said, I don't have a computer science background, but at the same time, it's been an interesting learning curve. So let me tell you a little bit more about who we are. And so we are West Texas A&M University. We are located in a town called Canyon in Texas. It's right in the middle of the Panhandle that you see, the top square of Texas. And you can sort of see the connectivity of this place. It's fairly rural. In this place, I'm going to talk about how HPC is a critical need and how the grant that we just got awarded through the NSF CC program has enabled some of these applications. We'll also talk about how we have shared our resources with the Open Science Grid, what were the opportunities and challenges, and so on. And finally, I'll conclude with some final remarks. And if you have questions during the talk, just feel free to post it on the chat window. I will address it either during the talk or after the talk. Okay, so who are we? So we are a historically teaching-focused driver for higher education in the Texas Panhandle. So we are gradually, slowly moving towards a more research-focused institution, but historically we have been pretty much entirely teaching-oriented. And as part of our WT 125 goal, that's our 125. That's when we'll hit 125 years of history in 2035. We want to attain doctoral status. So we want to attain something that is known as a regional research university, and this is something that our president is deeply focused and committed to, is solving problems that help the region first. Okay, so that is our primary and fundamental goal. With respect to our background, 47, nearly half of our students are coming from largely rural counties in the Texas Panhandle. 49% of them are first generation, and 26% are Hispanic origins, which makes us a rural HSI institution. So very close to the type of institution that we have been hearing about today morning. Our major industries in this area is agriculture, petroleum, and we are also a very good location for wind energy. Our location is one of the most consistently windy locations in North America, which makes us a very good location for harnessing wind energy. And so there are talks of our city, closest city is Amarillo. And so there's a lot of discussion about Amarillo going completely wind-based within the next 20 years. And you can imagine Texas and wind energy, where did that come from? Water and energy are our biggest challenges. Obviously, you can see petroleum, wind, the energies definitely are one of our biggest challenges. And we are also among the most driest regions in North America. So we are very arid, very dry. And so water scarcity is a very big issue that we're concerned with. So inconsistent with our, one of the things that our president is always trying to commit and encourage is for us to focus on issues that concern water and energy, because these are the most local issues that we want to look at. So with all of these problems, HPC is a critical need. It is instrumental for research and educational needs at WT and in the Texas Panhandle. It's an emerging need. There are a variety of data-intensive science drivers across various colleges in the university. So we have a College of Engineering, we have a College of Agriculture, College of Sciences, and so there are a variety of data-intensive science drivers, particularly with respect to the industrial challenges that I mentioned earlier, such as if you're looking at agriculture, we're looking at energy. There are many areas where you can look at data-intensive applications. So the role of computation in science engineering is generally well understood, but a knowledge gap exists. And this is what we're talking about with respect to the missing millions, or you can talk about just in the general sense of even in terms of experts, there's a knowledge gap. People who have been traditionally working in science and engineering fields, many of them may or may not know how useful computation can be. They are interested in using computation, but they often don't find high performance computation particularly accessible. So there's both an accessibility gap and also a knowledge gap. And this is something that we are trying to improve, is to understand how we can improve the understanding of these computational tools in both the undergraduate and the graduate population settings. As I mentioned, we are historically teaching focused, so we do not have a doctoral program. We do have a doctoral program, but in general, we are still emerging in terms of our doctoral and research capabilities. So in that sense, our computational tools are primarily going to be, a lot of it is going to be educational and curriculum based and emerging research needs. So let us talk about our CC Star Award that we got awarded. So as Kevin mentioned earlier today, the CC Star program invests in cyberstructure across US colleges and universities for addressing various scientific needs. And in this context, we applied for a CC Star Compute Award in 2019, and we got awarded in September 2020 to acquire and administer a high-performance compute cluster. And so we finalized our configuration in fall 2020 and installed it on campus in early 2021. And fortunately, we were able to do this before the chip shortage, so we avoided that narrowly. So we installed it in our data center, which is well connected to all of our various colleges. One thing that I would mention is a lot of small institutions may not have a very well-equipped, let's say, IT staff, but in our case, we did have a pretty well-equipped IT staff, mostly because a lot of our education is focused on online degree programs. And so we like nearly half or about half of our enrollees are online. And so, and this is something that our president is also interested in, is like having a 50-50 division between on-campus teaching and online teaching. So that's one of the reasons that we need to invest in suitable IT staff who can handle all these needs. And of course, this is a historic moment for our college. We have never had a high-performance computing cluster before. We have been traditionally teaching focused, so this was a historic moment. Also intimidating for me personally, because we never had it before, but at the same time, very, very historic and important. So let me talk a little bit about the progress on our award. So this is what we ended up purchasing. We purchased a Dell high performance computing cluster. And I wanted to mention that initially we had envisioned a different type of cluster, but when we looked at our science drivers and we communicated with our vendors, we found that we needed to redesign our cluster. And so in this sense, like whenever you're designing a cluster, it's always a good idea to just talk to your vendor about, what your application needs are. They'll often have a much better understanding of how to design the cluster than you might. So anyway, we ended up with 10+3 computational nodes with AMD processors, and 3 of the nodes had NVIDIA GPUs. We have the Cent OS operating system, and I'm not sure what that's going to be in the future, but that's something we want to keep in mind. One thing that we did change a little bit from our original plans. So we had initially planned for an open source cluster management and monitoring setup, but considering we had a limited experience in the open source business and we wanted to make sure that our cluster was up and running as soon as possible, we decided to go towards a vendor, a commercial cluster managing software called Bright, and that has worked out well for us. and when that license runs out, maybe we'll probably move on to a more open HPC based approaches for cluster management and monitoring. So we use the Slurm package manager and Slurm job scheduling, and for package management, we've been using SPAC, and that has been really, really useful for just handling all our various packages. So these are some of the key goals. So there's a lot of text on this slide, but these are basically some of the key goals and science drivers that we are looking at as a part of fostering and supporting our CC Star award. So you can see that one of the key things that we want to do is to develop courses and course components that utilize CI facilities, especially with respect to workforce development. And that is something that is very central to what we want to do as a university. Okay, so let me move ahead. So let me give you a little bit of the timeline. So in January 2021, we ended up getting the cluster on our campus and installing it in our data center. In about 3-4 months, we were able to enable established remote access via campus VPN Duo to the compute cluster. So May 2021 is when I was able to access the cluster either remotely or from my office. So it took a while, and a lot of the reasons why it took so long is because our IT staff was, although well equipped, they were just dealing with a constant barrage of cyber attacks, and this is probably what most IT staff are involved in, just dealing with cyber attacks a lot of the times. And in August 2021, I taught a graduate course on HPC applications and engineering just to get the stage set for students to use HPC for coursework. So, and I'm hoping that I can use this as a template to encourage other faculty in our college to either develop course components or courses that utilize HPC for coursework. And in December 2021, that's when we throughout all this time, we were in communication with the Open Science Grid as to making our cluster available for OSG jobs. And in December 2021 is when we established a full communication with the OSG pool so that OSG could submit jobs and they started to run on the cluster. And in 2022, I've been working on reaching out to other colleges other than just the College of Engineering. So we have had a lot of interest in bioinformatics and computational agriculture from humanities and business colleges to see how they can use this cluster. And so that is something that is going to be a continuing effort, outreach effort. Just to give you a little bit idea about what the timeline looked like with respect to OSG. So you can see that the first pilot jobs started running, I think this is about in November of 2021. And in December 2021, about a month later, that's when the payload jobs started running. And I'm going to tell you why there's a gap between these two. A lot of it has to do with the fact that the payload jobs need some sort of network protocols for them to run. I'm going to talk a little bit more about that. So far, we've been able to contribute about 318,000 hours to the Open Science Grid. So let me talk a little bit about how we shared resources on the OSG. The OSG website, Will and Lauren and Frank talked a little bit earlier today about how you can connect your cluster or your compute resources to OSG. I'm not going to go over all of them, but I'm going to talk about the key ones that stood out. So first thing is you need to allow OSG to log into your cluster. And so for them, and this required a little bit of attention because the Open Science Grid compute entry point cannot use Duo. And that is true. And all users that are using our compute cluster are using Duo. So we needed to allow for some kind of whitelisted SSH access so that the compute entry point can log into our cluster without any kind of Duo. And the second thing, and this was the biggest challenge for us, was to allow for outbound network access for HPC worker nodes. So Lauren talked a little bit about how the OSG workflow works, but essentially what happens is OSG submits something called a pilot job to your cluster, and the pilot job is basically like an assembly, or at least a job manager of its own that manages a lot of payload jobs. And the payload jobs are the actual jobs that are run on the cluster. And the payload jobs often need to access the internet to download all kinds of data files from various locations. So we needed to have outbound network access for HPC worker nodes. And this had to be ensured with unrestricted port access. And this is something that we had a lot of trouble implementing, because our cybersecurity policy is basically to limit access. Okay, so if you want to do something, what is the most limited way you can enable something? And with respect to the OSG configuration, you almost want unlimited access with respect to HPC worker nodes. So that was one of the bigger challenges that took us a while to enable and make sure OSG's jobs started running. With respect to resource sharing, we have our initial strategy so far has been to have exclusive partitions for OSG and for local jobs. So for example, at the initial stages, we might partition our cluster into one set of nodes for local jobs, another set of nodes for OSG jobs. And that is what we have been doing so far. But what we want to do, and we are working on this right now, is to have some sort of overlapping partitions. In this case, OSG has access to all the nodes of the cluster, and so do local jobs. But local jobs get priority factors, or get a higher priority factor and possibly preemption, so that they can run jobs and OSG can run jobs without necessarily competing too much with each other. So that's what we are going. Let me talk a little bit about the overall challenges. And we already spoke a lot at length today morning with accessibility. So one of the biggest challenges with respect to teaching the course is the Linux terminal. A lot of the time, HPC traditionally has been based on a Linux terminal. And a lot of times when I'm looking at people who want to use high computation, they may not want to learn another operating system. And this becomes like a barrier to them. And so trying to find ways around using Linux has been one of the challenges. Another thing has been open on demand, and that is a very useful and promising development. That is something that we are interested in setting up, but unfortunately it requires a full-time equivalent. And we are not entirely sure whether we have enough IT staff to implement open on demand. So maybe if there was a remote solution for open on demand, that would be great. I'm not sure how that would work. Jupyter notebooks have been very, very useful. And this is something that I wanted to do right at the beginning, because Jupyter notebooks can run on your cluster and you can convert that into a Jupyter code, into a Python code, or some application that you can run directly on your cluster. So using Jupyter notebooks have been very, very useful in terms of promoting access. And one thing that I would like to implement and see is if I can run Jupyter notebooks directly on our cluster. And another thing is obviously trying to see if there are non-Linux interfaces. Open on demand is one of them. One thing that I've noticed that for a lot of students, even those who are doing computational work, for example, in engineering, you do a lot of computational work, whether you're using Autodesk products such as Fusion or Inventor. A lot of them are doing finite element type calculations, which are technically computational work. But unfortunately, they can't always be run on the cluster without additional licensing. So one of the issues has been a lot of the softwares that are commercially available are very accessible to students. And so transitioning them to a cluster or an HPC cluster where they have to learn a lot of new software just to do the simplest of jobs can limit their accessibility. The other challenge is obviously cybersecurity with respect to networking and configuration changes. And finally, I wanted to mention the fact that computation is fundamentally interdisciplinary. So finding ways to introduce that into an undergraduate curriculum, there's opportunities in there, but there are also challenges because it involves mathematics, it involves computer science. A lot of the time, students who are interested in computation or might be involved in data science, they may not have the necessary programming background. So the question is, do we invest more in training so that they can use these tools, or do we make the tools more accessible to the non-programming aware? All right, so final remarks. I'm already gone way beyond time right now. Sorry about that. I just wanted to talk about like what does the future of HPC look like in rural academia? And this question is always going to be there. Do you want to use a cloud or local clusters, or maybe it's just a bit of both? And there's a recent paper by Reed, Gannon, and Jack Tungara about what are the challenges with high performance computing. Will people start to use clouds because conventional vendors have much more funds just to invest in resources, and so maybe a cloud-based approach might be something that we might look at. But at the same time, if you want to encourage training, maybe a local cluster might be the right way to go. Interfaces can open on demand, can be remotely managed like an OSG compute. I know OSG staff have such a lot of time on their hands to manage all our needs. Surely they can manage open on demand as well, but maybe that's something that can be done so that, you know, small colleges like us can invest just more on the science aspects and not much more of the IT and administration aspects. Applied curriculum, one of the things that making, you know, HPC more accessible and more prevalent is to find ways to have practical applications. So one of the things I taught programming in one of the classes, and so most of our students are rural. And so one of the students came and told me once that, oh, one of the reasons that he likes programming is because he wants to fix the tractors that he uses in his farm, and the software that he gets from the tractors are very hard to fix and diagnose, and they charge a lot to fix these farming equipment. So the needs of what the motivations for what all these students have to learn programming and computation might be completely different from what we are used to in let's say a research enterprise. So finding out what these areas are, such as, you know, in our case, it would be agriculture, petroleum, wind energy, and other institutions it might be different, but finding those areas are one of the best ways to attract students to some of these HPC-based workflows. Future work, in our case, it's going to be obviously to promote outreach, user base, and training. We have a hackathon coming up next month, and I'm hoping to use the HPC for that as well. So thank you again for your attention, and this went a lot longer than I had imagined. Thank you very much. And some acknowledgements on the right of people who have helped a lot in this endeavor. Thank you very much.
All right, thank you, Anirban. And you technically only went over by 1 minute because we've got the time in this session broken up kind of oddly, but I think we can take one question while Bennett gets set up.
Hopefully I'm set up.
Yep. All right, Anirban, can you unshare your slides?
Yeah, okay, I saw. Sorry, what was the question? Stop sharing?
Yeah, if you could stop sharing, I think we can get Bennett set up while we take one question for you. And okay. I'm going to call on Ryan Fisher.
Now I'm unmuted. Hi, I had a general question that might not just be for you, but for anybody. We were looking at a CC star, applying for one soonish. And we were also, we were getting a couple compute nodes now in advance that we're going to set up locally and set up a small cluster for. Now, the question I was going to ask is, does anybody have an experience or impression on applying for a CC star and getting one, and whether it would be beneficial to have an open science grid connection / cluster set up a little beforehand, or if it's good as a selling point when you're trying to get that award, or which way kind of should come first, chicken or egg kind of thing?
From my experience, we didn't have a cluster to begin with. So our open science grid came later. I mean, we did mention that in our proposal that we would be connecting it to the open science grid. So that is something we mentioned in our proposal, but we did not have an existing open science OSG-based connection. Yeah, so it's something we developed as a part of our work in our proposal. I'm not sure if that answers your question.
So beyond Anirban, I think we've seen both, Ryan. We've seen people who did what you're just seeming to be heading towards, and we've seen people who have had nothing and starting from scratch. So it doesn't seem a huge deciding factor one way or the other. I think more important from what I've seen seems to be that you have to have your science story lined up, and who is going to use this, and what the institution and how will this all come together and satisfy a need at the institution.
Yep. And regardless, we OSG are happy to collaborate with you in developing aspects of your CC STAR proposal, especially around science drivers, any integration with OSG, whether through resource sharing or bringing compute resources through OSG to your researchers. So please bug us about that. All right, I'm going to move on. Any other questions, maybe throw them in the chat for Anirban or join us in the discussion session after this, but I want to transition to Bennett so that we're not falling too far behind time.